Hello and welcome. Today I thought I would talk a bit about Hadoop and Hive in particular, and how these things kind of go together. Start off going through a discussion of how to do it if a person wanted to do it inside of HD Insight. Then we'll move over and go through the things that are necessary to um, do it inside of the Windows subsystem for Linux so that you don't have to do things in the cloud. So jumping through what we'll talk about is basically the process you go through to create a cluster, then how you connect to it, and then how you delete it. Looks like I need to fix my slide there, because that doesn't have anything to do with what we're doing. So continuing swapping, here we go. All right, so moving into how do you create an HD Insight cluster, and I'm doing this way because it takes a while. So and we can essentially kind of skip ahead here. So you go and we want to create an Azure HD Insight cluster, and it's going to be that top one there, I believe. Oh no, it's that one. So you want to make sure you do get the thing that says from Microsoft. Don't get some sort of third-party thing that's might happen to have the same name. As always, you want to create a resource group so that you can then delete everything later on as you want to. Pick the type of cluster you want. In this case, you want Hadoop. Give yourself a password for the username, the admin user. You also potentially want that to be the same, or it will be the same as your SSH login, so that you want to keep those two things the same, so you don't have to remember two different passwords. And you can leave the SSH user as SSH user, perfectly fine, and you can use it towards the same as the cluster. You want to go through and set your primary storage to be either in the data lake or inside of a storage account. So in that case, you want to probably change the name of that container there to be something so that you can then and I'm taking a while to figure out that I want to create one, but change that container name to be something so it's easier for you to remember, so that whenever you want to use an existing account, you can, if you happen to delete the cluster to save money, or maybe you don't get everything done in one go. And then with the rest of this, you can pretty well skip through. You do want to do the configuration though, and you'll want to go down to at least that A2M V2 is a good choice as the A2 V2 for the Zookeeper. You only really need one worker node because you're not going to really be doing anything at scale here. So you want to keep it small and cheap, and also make sure you remember to delete it after the fact. Then you're going to wait around for a while for it to do this. We're going to skip this bit. After it's done the validation, it gives you an estimate on what it's going to cost to run it. So by selecting the processors that I mentioned there, we can get it down to basically 50 cents per hour. So that's not too bad. You don't want to you want to probably go get a cup of coffee whenever it's doing this bit, because it's going to take a while to actually deploy the cluster. And do make a note of on the left side there where it says the important is going with the ones that I have there will work. Some, if you try some of the default values, it may not work because of limitations inside of the various environments. So keep that in mind. So talking about what is Hive and how do you care about it, and why would you use it. So there's various ways that you might want to interact with it. If you're doing interactive queries, you might want to do either the Hive view of it or the Beeline client, or you may also want to do something with Visual Studio or Visual Studio Code. VS Code is the pretty much free version of things. There is a free version of Visual Studio. The key differences there is kind of the intended usage. Visual Studio Code, or VS Code as people typically call it, is a lighter weight sort of solution. It doesn't contain as many templates and such as you might have in Visual Studio, but it is pretty lightweight and pretty quick and pretty easy to use. It follows a directory sort of structure approach versus a solution approach. And if you're doing things for batch processing, you can also do things through a REST API or perhaps through PowerShell, depending upon what kind of clients you're coming from. VS Code, the process is pretty simple. You go through and click on File, Preferences, and Extensions. Go and search for the Spark and Hive tools. Pretty cool extension and pretty useful. So to see that in motion, extensions, and then go and look for Hive, and you'll find Spark and Hive tools there at the top. And go ahead and install that. It's pretty cool stuff. Does make it to where you can then go through and run queries from inside of Visual Studio Code and get back the results. So a little better experience than running it at a command line. So you will need to do some linking of it. So one of the things you need to do is go through and do the file preferences settings. Then you're going to search for Azure Cloud, and then you basically need to sign into it using your credentials so that you can essentially have access to those resources inside of it, so that it knows where to run the commands. And you're doing this basically by creating a link to the cluster from inside of your environment. These steps you do basically one time per life of the cluster. You might not want to go to this trouble because you're only going to be doing something pretty brief, but if you were to be doing something longer, you might want to go to the trouble. So here's an example of running a query against the cluster. So that's because I've connected to it this way. Your other alternative is to do what I've mentioned in the past, which is basically SSH onto the cluster and run it a console line, basically. So that is one choice. And basically what you'll find as you're running your queries is that it is really close to the SQL you're familiar with. You do want to remember to put the semicolon in the SQL statement. So here we're going to go through and basically delete the cluster. So it's in order to do so, it basically makes you type in the name. Probably a good idea to go ahead and delete the resource group as well once things have finished. So a useful sort of exercise. And it will take it a while to do the deletion, so expect that. If you want to go and recreate the cluster, which is something that you might need to do either on this project or on Module 2's project as well, you can go through and basically select, rather than creating a new storage account, and pick the one that you previously used. So in that case, it's the ALD Big Data one that's listed there below. And you will need to reconnect your Visual Studio Code if you happen to go that route, because it's a different cluster. So the reason you might want to do that is to make sure that the something that you might have loaded is there. So if you went to the trouble of uploading a particular file or something, then you might need to do that. And then here's an example of doing essentially Titanic within a cluster. So basically you have to have the files. One way to do that is to use Storage Explorer to get the files into the cluster. And that's the Storage Explorer. The online version, which is what you're seeing here, is sufficient for that. There is a Storage Explorer that is an installed program. Probably don't need it if all you're doing is this, right? So if you're basically just going to use that, then you can go through it. And then you want to basically go through and this is creating an external table. So two types of tables, right? Internal, which is what happens if you don't use the word external, The external table is essentially something where you're saying, hey, I want a table, but the files are actually going to be in some other location, so you basically need to tell it where it's at. You can also do things like skip the header, because there are column names in that first row. So line 22 down there is telling you to skip it. Line 21 is telling you where within the storage account is it placed, and then the rest is giving it the schema so that it knows what to do with it at the data types that it is. And also notice that we're not doing a file name there, we're just doing a directory, because it's smart enough to figure out that oftentimes whenever you're dealing with these sort of environments, there are multiple files that are actually treated as one logical thing. So that's one thing to keep in mind. Beeline is the command line version. There's Hive is also a command line, but if you're connecting something that is remote, you don't really kind of have that choice. So the way you connect to it is by first doing SSH. So you click on inside of the portal over there where it says SSH plus cluster logon. You click on that, and it gives you the command that you'll run to connect to your server based upon the host name. You could figure that out yourself, but it makes it really easy to basically just copy that and then paste it into a command line so that you can actually SSH onto it. SSH may or may not be installed on your computer. If it's not, go Google SSH command line and you'll find it. So here's some queries that are being ran against the training and test data, just to see some counts based upon gender. And with that, I've reached the end of that discussion. Moving over to kind of the second part of what I wanted to show, and this one will be more interactive because it's easier to do. This has changed a little bit recently. Previously you had to go through a few hurdles to get WSL installed. Now you go into Store, so Microsoft Store, if you're running Windows obviously, and search for Windows subsystem, and spell it right, Linux. So what they've recently done is move it into essentially an app inside of the store. So you go in here and basically install this, and it gets it to where you're into WSL a whole lot easier. Once it's done so, then you can basically open it, and it'll open it up as a command prompt or as a window. So I can go ahead and do that and show you what it looks like. So basically it's just a command prompt, and it's opened onto that particular the default version of whatever you've installed, because once you've done this bit, you'll also search for Ubuntu or whatever flavor you like. In this case, I'll be showing you 18.04 LTS, so the long-term support version of this version of Linux. So what I prefer is the terminal preview. So also in the store is, if you look for Windows Terminal, you'll find a preview version of it down here. And what this does is allows you to have multiple command prompts open doing different sort of things. And in particular, the default version opens up onto whatever you've specified as being the default version, or whatever you want it to do whenever you just run the program. But you can also open up different distributions. In this case, I've actually don't want it to be the 20 version, because that's where I'm doing some other work. But if we're doing something with 18, you basically pick it and it opens up a command shell. So the first thing you probably want to do is get into your home directory. So it opens you up inside of your users folder inside of Windows. So the same folder that is the root essentially of your user profile is where it starts out. And that may be fine if you want to use that as the place where you store your files. I chose to do it over inside of what's basically listed at home and then my username. So what I've already done ahead of time, previously I've talked about getting Hadoop installed and configured. Once you've done that, the only thing that I haven't really set up correctly yet is to get it to where it auto starts. So first thing we always try is, can I SSH to my local host? And I can't because it's not running. So we need to go and start up the SSH server. To do that is I always forget the syntax, so I'm copying it in. So it's just sudo service SSH and then start. Give it your password. You're asked a username and password whenever you first install the application inside of Windows Subsystem for Linux. So at the point that you install Ubuntu 18.04, it's going to prompt you on the first run to set up a username and to set a password. It's just for security purposes. So at this point, I've started up SSH, and we check to see, can I SSH to myself, even though I'm really not going anywhere. It's how Hadoop and related tools talk to each other. So the next thing to do is to go into the sbin folder, just because I'm starting this up, and run the startall.sh, and you typically have to do the / just because of the way the Linux environments work. So at this point, it's actually going and spinning up all of the various parts of Hadoop, and you kind of have to do that to make sure it's up and running. And a check would be, once it gets up, to maybe take a look and see if you can list something on the file system, right? So the HDFS, not your Windows or Linux file system. So we can do HDFS, DFS, LS, and see if we can list some stuff, and we can. So there's actually some folders there. So the next thing you want to do is, I went back up to my home. I downloaded previously Apache Hive, so walking through the agenda so we can follow this somewhat, to try to keep me somewhat organized. These are the things that you pretty much do. There is the whole prerequisites that need to be in place before you can do it. If you've got Hadoop up and running, you've pretty much got all this other stuff done. So you do need Windows Subsystem for Linux v2 turned on. That likely happens by installing that application. If not, you have to go into the Windows system, turning features on and off stuff, and basically turn it on. And I talked about that previously. Then you have to make sure you have the Linux version installed. And then inside of that, you want to get Java installed. We walked through all of that in the previous discussion with my script that's available from my GitHub repository. So we do things like all these apt install of things to get everything installed, up and running, generate some keys so we can SSH onto the box, and so on. Start up Hadoop, and once you have all that done, you're in pretty good shape. The next thing is to go and download from typically a mirror, the version of Hive that you want to use. So you go into hive.apache.org, go to downloads. It says releases may be downloaded from mirrors, so you don't actually get it from here, and it'll make a recommendation for a mirror for you. So you typically use the one that's being recommended. Click on that, it'll take you to essentially a FTP sort of browsing. What you'll want to do is probably get 312, and inside of here you're going to basically do this, and so you want to copy that link address, right? And then once you've done that, you'll go back to your shell and do a wget-nc. I'm pretty sure that's right, for no clobber, and then paste in that URL that you did, and it says it's already there. So basically what you're doing here is saying, go and grab this file and download it into the current directory. there are lots of other ways you could do this. Because you do have the integration with Windows, you could actually download it into your Windows environment, and through Windows Explorer, open up essentially that folder down here in Linux. So once you downloaded it, you could go into 18.4, navigate to the home directory for your login, and just basically copy it over. It would be easy enough to do. And in fact, that's probably the easiest way to get data in if you're going to want to do something like load some CSV or something. So once we get the bits down on the computer, you're going to want to issue the command tar xzf, and then that gz file that we just downloaded. And basically what that does is expand it out into a directory. It's like unzipping it, right? So once you've done that, then there's some minor configuration you need to do. The place to know how to do that is back on the Apache website. There's go to Home and go to Getting Started Guide. And one of the things, the first thing it does is talk about installing and configuring it. So it does tell you the requirements. You need a version of Java and so on. And there are some challenges depending upon the situation with the traditional Java. That's why I'm using the open JDK versus the typical version that you might use. Also, they add an extra setting to theirs. Looks like a V. So feel free to use that instead of the one I used. Both are likely to work. So once you've done that extraction, and this walks you through, you're going to build it from a stable release and go and download it. And then you need to go through, once you've downloaded it, and go into the directory that gets created. So Apache Hive, and you're going to need to edit a few files, right? And it's you don't necessarily have to, because you can do what they do, say right here. That's going to be a one-time sort of thing. Your alternative, and what I outline in this PowerPoint, is you go in and edit your .profile. That's in your home directory. I'll show you that in a moment. But you also need to go down into the bin folder underneath of it and edit the hive-config.sh. And in particular, what you're having to do here is tell it where Hadoop is, because it doesn't necessarily know. And so basically I'll just type out the file, and you add that last line. That's the main thing you need to do, which is basically saying that Hadoop lives at that location, and you want to make sure it exists, because it gives you a cryptic error message if you get it wrong. So just for sanity, 3.1, and if it doesn't find that, then you typed it wrong, right? So that's the one thing you have to do, is tell it where it can find Hadoop. And that's because in this configuration, Hive is going to use Hadoop to actually do its processing, which is the whole beauty of Hive, is that it's basically going to produce a MapReduce job for you, and you don't have to do it yourself. Moving back to the home directory, if you do one thing that, if you don't know Linux, you may not be familiar with, you notice you don't see .profile here. Things that start with dot are hidden. So you can see if you do a ls-la, you can see that there's lots of different little hidden files here. .bash rc, you probably want to edit that one, and you also want to edit your .profile. So if you type out .bash rc, you probably want to add those last two lines to your file. And basically what that's saying is Hive lives here, and then I add that to I had the bin folder underneath of that to my path. By doing that, then I don't have to do the full name. The same thing for .profile, a similar sort of concept. I'm basically doing the same thing there as well. So once you've done all that, you've got it configured, and then you want to actually do the running. But before you do something like, say, type in the word Hive, you want to do essentially create a schema. So you do schema tool, and then you say db type and type the word derby, and then dash init schema. Once you've done that, and assuming it tells you life is good, then you can actually run Hive, and we'll be running Hive interactively here. So I've already done the schema init, and if the demo gods are smiling, typing in Hive should start up the Hive command line interface. This is running it kind of in process versus setting up and running a server and then connecting to the server through Beeline. So this is going to be something that goes away. It's probably long-term a good idea to do it correctly if you're actually going to be using Hive long-term in this sort of environment. I'm not. This is for a demo. So once you're inside of here, you can then start issuing commands. So I've already done some of these things, but I'll go through them again. So you can do show databases. And what that does is tells you what are the databases that exist inside of the environment. And there's two of them here, default and test. So I created test earlier, but I can create something new. So the command here is similar to what you do pretty much everywhere else. Is you do a create database and then say demo. And what that does is creates a database named demo. So then if I do show databases, it's now present. So we've now got default, demo, and test. You want to typically use a database. So you issue the man use. In this case, I'm going to go test because I've already done some stuff there that I want to see. And yeah, there's no ls. So if you type in something that's not the right word, it tells you in a rather cryptic way what's wrong. So it didn't know what to do there. What you can do is show tables, which basically is telling you what are the tables that exist inside of this environment. In this case, I've already created a hello world table, and so I can create another one. I'll call it create table hello world demo, and then you give it the schema. So in this case, I'm going to say it's a string, and maybe I want to say times is an int or something. And so what that does is goes and creates that table. So then if I do a show tables, that table will exist now, right? So I've got a hello world. Just like in most things, you can insert values. So in this case, I'm going to insert hello world demo. I'm going to insert a record into that called Alan. And probably lovely PowerPoint change to the curly sort of thing, and I probably want to go ahead and give it the second value, which is times as well. And so right now it's actually going through and adding that to the table. So if we do a select star from hello world demo, if things go well, you can see hello and the number 1. So that is what's inside of that table. Similarly, I'd previously installed a record of just Alan and hello world, and show table. I think that'll work. We'll see. Yep, nope, didn't work. Describe table. Maybe that. There we are. So describe in the table name lets you see what the structure is of that table, and that it, in this case, hello world just has a string. Hello world demo should have a string and an int. So you can see the schema of the table as well. And then I've already shown you the select. So that's basically the getting started sort of stuff. So that is the simplest version. So what you have here on the screen, and I'll go ahead and copy it into Notepad. Actually, I'll be all fancy and use Notepad++, and paste that in. So what this does, and I cheated to create this because I'm lazy, and I'll show you how I cheated to do it here in a moment. But basically, this last bit is kind of what you care about, because what I'm going to do with this is then insert a CSV into it so that we can we can use it. So the syntax here is pretty much what you're used to seeing with inside of SQL. You start off, you've got your parentheses here that describe the columns, making that a little easier for you to read. And then the thing at the end, which is kind of the additional stuff you want to say. If you wanted this to be an external table, meaning that the data wasn't being managed by Hive but by something else, and it would persist after you dropped the table, you would use the word external up there and include a location, right? So you'd have external between create and table, so you'd say create external table, and then before this semicolon you'd have something that says where the location is, and you might not do this field delimited thing, right? So that's basically that. Once you've created that table, and I've already done it here, so if I say describe, actually let's show, if I could type tables. I don't want to type all that, so I'm just going to copy it and say describe that. And again, you always have to put in that semicolon. If you don't, well, I'll show you what it'll do. So it'll basically do the continuation, and then when you add it, in that case because I hit the wrong character, so you want to include it there at the end, right? So actually if you do and don't include it and then do, it should work because white spaces and carriage returns don't matter. So moving back to kind of our discussion, the next thing once you've created this table is to load some data into it, and this command will do that for you. So basically it's going to be load data, and then because it is going to be on the actual computer itself and not in some other location, you include the word local. So load data local, and then an in path, which is the path of the thing that you're wanting to load. So this is where that file resides. And if you don't believe me, I'm going to open up a separate terminal onto this one and do an ls and then type in that name minus this, and you see that that really is where it is, right? So so you do this the load to load the data in, and again load data local, and then the location where it is locally, and then I included overwrite into table, so that basically means truncate the table and reinsert each time you run the command, and the name of the table to do that too, and it persists the schema. So I've done that, and you saw that a minute ago whenever I did a select star from that, right? Not terribly easy to read, but if you do something like instead select distinct state from, I don't want that, I just want this. You can see it actually goes out and it's showing you all of the states, and because I was sloppy, I didn't skip the first row, so you can see that state is actually the header out of that row. Also, interesting stuff here that it kind of skips right past. Launching job 1 out of 1. Number of reduced tasks not specified. So you can see already we're kicking off a map reduce job, and it even here it says map reduce jobs launched. Stage 1, it does an HDFS read, HDFS write, and then the total time it took to do its thing is almost instantaneous, other than the overhead of going out and getting the data and coming back. So we've got some data, we've got a table, we loaded it. So now you may want to do some interesting queries. This is just to show the example of running a group by and order by, right? So we're basically saying select the sum of the permits that were issued, and we'll call that summation the total permits, and I want to know what state it's from that table, grouping it by the state, ordering it by the total number of permits in a descending order, so that the state that issued the most permits will be the highest, and then in descending order, right? So kind of cool, and showing it up and running in a nice sort of way. So here are some references. I've pretty much opened most of them up. This is not terribly, I mean, you can go look at it if you want. It's basically kind of a restatement of some of these other things. So with that, I'll show you what I did to cheat. And cheat's not the right word. It's just simply making my life a little easier. So what I did was I went into community.cloud.databricks.com. And this is just a free version of Databricks, right? So that we can basically use it for free. You have to sign up the first time you do it. You do have to have a cluster up and running to do much. And so you basically want to say, create a new cluster. Actually, I probably want to see if that'll, in the past it wouldn't really let me start it, but let's see if it will, because it usually gets kind of confused. So basically it's a kind of a limited sort of environment. You can only have a single node cluster, so it's not going to be doing any terribly powerful stuff. But what I did was, one of the things they make it really easy is to import data. And also a data point that's worth knowing is that under the covers, Databricks is using Hive, right? So it's kind of a way to get it easily up and running. So I'm going to go and navigate down into this class, go get the data. I've previously downloaded it. It's in the course room. Go into here and drag that file up here, right? So pretty easy whenever it actually goes. And what that does is takes you to a create table wizard. You have a choice of either creating it in the UI or creating it in a notebook. I selected notebook. And basically what it does is writes the code for you to basically it put that file into a place called file store on its internal file system. So a similar sort of thing, HDFS, but they call it DBFS, Databricks File System. And there's some choices here, such as infer schema. Yes, please, we do want to do that. And the first row is indeed a header. So if we say yes, the delimiter is a comma, and then the rest of this we don't need to change. The cluster's probably not up yet. Let's see. But moving on down through the rest of this, because I have done this before, I'm going to have an _1 at the end of it, because there's another table, and we'll actually shift over to that notebook here in a moment. And basically the key thing here is at the very end to uncomment this line. And what that does to walk through this example, and this could be helpful because this is Spark, right? And that's something we talk about soon. So we have some variables we're setting up. We're saying where the file is, what type it is, what sort of approach should be used to do the reading. So we're saying read Spark read.format, and it's a CSV. Infer the schema, and you do this dot option to add additional things that you want to happen on this whole read. End result of all that is you get back a data frame. A data frame is kind of like Pandas data frame, except for Spark, built on top of RDDs, so resilient distributed data sets or data frames. So the idea though is that it knows how to do things in parallel. Not so relevant right now, but it is relevant if you want to do some real processing. So we have we want to assign a name, so we can basically tell Databricks to say, take that data frame we just created by reading this stuff and expose it as a temporary view. So then once you've done that, you can actually run something that looks an awful lot like Hive queries against it, because it is Hive queries. And so you can actually do a select from it and get back the values from a temporary view, right? So this is a temporary view. And I'll, for simplicity, I'll make them dashes here, right? Then this last bit, what we're saying is I want to create actually a permanent table, not just a temporary view. And I'm going to want to call that something like _1 versus the -1, just so that they're different names. And basically what I'm saying is write this out as a Parquet file, but make it into a table. So once that's been done, maybe it'll let me do it this way. And go ahead and let this run. Launch and run. Sometimes it gets confused because I've got, it tries to create more than one cluster. So this is what I did previously. Same basic thing. I went through and I created, I uploaded the file. I changed the things that we just talked through. I turned it to where it is infer schema, which basically means it tries to figure out the data types of your columns by looking at them and seeing what it kind of looks like, right, by looking at a certain number of them. You don't want to do that most of the time in a production sort of environment at scale because it's expensive to do. But for what we're doing here, perfectly fine, because this is kind of a one-time thing. And then here you can see I actually did a select from it. Notice the column names are what it was inside of that CSV to prove I'm not fibbing. We can open that up in Excel. And no, Excel is not a big data tool, but for this case it makes it really easy to go through and see it, right? So just an easy way to visualize a relatively small file. Then the next thing, I went ahead and wrote it out. It's not going to succeed here because it already exists. And then there's ways to get around that, but regardless, what I did was this line right here makes your life a lot easier if you go this route. So I basically say show create table, and what that does is give you back the script that you would use to create your table. So in this case, because it's longer than what will fit in here, they give you this nice little window that you can actually slide around, or you can click in here and say copy. And the reason to do that is because it gives you the schema that I have up here, right? So all you have to do from that is, we don't want to use Parquet. We do want to say that it is row format. Rows are formatted or terminated, essentially the fields are delimited by commas. So we want to add that line, and you probably don't want to specify what database it's going into, since we've already used a database. And at that point you're good to go, right? So you don't have to go to the trouble of writing that whole DDL yourself. So easy way to get it cranked out. So and then to kind of make sure that I knew what I was doing, I wrote the query here to do the summing and grouping, and you'll see that those results are the same as what we saw over here, right? Just in a prettier sort of format. And that the numbers match, right? So you can do lots of interesting stuff here. You can do joins, you can do whatever. Under the covers, it's going to be creating, in the case of what we've got on the Windows subsystem for Linux, it's going to be creating a MapReduce job and submitting it to Hadoop. Inside of Databricks, it's targeting Spark. So instead of doing MapReduce, it's doing a Spark job and running it against it. You can actually see here the Spark jobs if you're really interested in what it's doing under the covers, and you can even go through and see what these various stages look like to see what all it did. And it doesn't like that because I should do this if the cluster is up and running. Did I switch databases? Huh, that's interesting. So it dropped my stuff. So we'll go ahead and go through this again. So I'm creating a data frame, and it's doing a display, which makes it to where you can see it in a nice, pretty cool sort of way. You can actually do some visualizations here if you're so inclined. We're not going to do that. Then I'm going to go through and create the temporary view. Didn't mean to switch that, but that shows you that you can do them in a different way. I'll switch back over here to the grid. So I've created a temporary view. Then I'm going to run a query against that temporary view just to to show that it actually works. Click the plus between the two to do something. The magic cell, because this is a Python notebook, you have to tell it that you want to write some SQL, and then you can just say select star from and the view, not the table, and it will issue a Spark job and return back the results. So we can then also go down here and actually write out the table as a permanent table, and it's kind of in a weird state that it thinks it already exists, but that's unusual. Probably need to drop it and then recreate it because it's a little confused. Does it actually have any data? So that's really interesting. So I need to clean up my environment, but basically that's the idea. Is an easy way of getting it is to drag the file up into Databricks and then create a table. You can also do this experience through say a different file, such as Titanic. And create it with a UI. You have to specify a cluster. You do a preview and it kind of lets you see what it thinks the data is going to look like, and you typically want to go ahead and turn this stuff on and make sure that it really is a CSV, because I'm not 100% sure it should be a CSV. And then once you're ready to do it, so it says, okay, I've inferred the schema. I know that these are ints, these are names or strings, and so on. Then you can click on this and say create table. Once you've done that, you've got your table, and then you can just issue your, and it actually succeeded even though we saw that error message. Because if we click in here, you can see it exists. It's in a mood tonight. So anyway, that's the basic approaches. Once you've done that, then you can go in and do a show table. Anyway, anyway. If I could spell. And you can see test tab 1 exists, and so you can issue that same show create table command against it and get back the schema so that you could do the similar process. And with that, I'll go ahead and wrap this up. Sorry for a few of the meandering sort of points. As always, if you have any questions about this material, let me know. Stay safe, and we'll talk again soon.